Hello everyone, welcome to the channel. In this video, we will see a problem on D'Alombard's principle or Newton's second law. The problem states that we have two masses of A and B of 7.5 kg and 27.5 kg respectively as shown in the figure. The coefficient of friction between mass A and the plane is 0.25 and between mass B and the plane is 0.1. So we are supposed to find the forces between two masses as they slide down the inclined plane. Okay. So first of all, write the given data. So we have two masses, that is mass A equal to 7.5 kg and we have mass B equal to 27.5 kg and we have coefficient of friction of mass A as well equal to 0.25. We have coefficient of friction of mass B equal to 0.1 and the inclination of the plane is theta equal to 40 degree. Okay, so these are the data they have given to us. Now what are we supposed to find? The force between two masses or two blocks, two masses. I'm going to take this as F question mark. Okay, so to solve this problem, what we can do is we can consider FBD for both the blocks separately. So considering FBD for block or mass A. Okay, now they have the inclined slope of 40 degree. The inclination is 40 degree and we have a mass of A. Right. Okay, now on the block, what all force will be acting? First force will be acting as a normal, that is a normal reaction that is acting perpendicular to the block, and we have a weight of the block will be acting downward. So weight of the block will be acting downward. So since the slope is inclined 40 degree, the weight will be also making an angle with respect to y axis is 40 degree. So I'll take the theta with respect to x axis. So if that is 40 degree, then this will be 90 minus 40 degree. This will gives me 50 degree. So the weight is acting downward, having an angle of 50 degree with respect to x axis. So it is an inclined force. So what we can do is we can resolve the force. The weight is of block A is 7.5 kg into 9.81. So this gives me, if I multiply 7.5 into 9.81, this gives me 73.575. So I'm going to resolve this forces into two components. One is a vertical horizontal component acting downward, 73.575 cos theta. I'm taking this with respect to x axis. So we have one more component of weight that is acting downward, that is 73.575 sine 50. Okay, so this we have resolved the weight component into two components. Now if you see, we have the direction of the block is downward, or else we can call it as the acceleration of the block or mass A. Okay, so these are the forces on reactive force acting on the block. There is one more force. If you see, we have a block B, we have a mass B, it's or else it's attached to the block A. So that means from the block B, we'll have a force on block A as well. So the force will be like this in the downward direction. Okay, from the block B to the block A will have a force. So we can represent in this way. So already there is a weight component over here, so I'm going to draw it in this direction. So it is from right to left. So this is the force between the block A and the block B. So this force is from block B. Okay, so I guess so if this is in downward direction, so we'll have a frictional force as well in the opposite direction. So I'm taking frictional force as F of F. The formula for frictional force is mu A dot normal, right? Okay, so now what we're going to do is we can use the Newton's second law. By Newton's second law, okay, so we know that f of y equal to m into ay. So why I'm going to use this equation, because I need to find the normal value as well. Okay, so the block is moving in downward direction, that is the horizontal direction. So the block is not moving in y direction, so this will become 0. So summation of f of y will be equal to 0, since ay, the acceleration in y direction is 0. So we have to frame the equation for all the y vertical forces. First force, we have a normal which is acting upward, so it will positive n. We have one more force, it is acting downward, that is 73.575 into sine 50. So this is one force, it is acting downward, so minus 73.575 into sine 50. This will be equal to 0. Okay, so if I do the calculation, I'll get n will be equal to 56.362 Newton. We can put it in the calculator and you can get the value. So now we found the value of normal. Now we're going to use the horizontal formula. F of x will be equal to mass into acceleration x direction. Okay, so now in the body we have to consider all the horizontal forces. So if you see here, the direction is downward, we have the direction is downward. So in this direction, what all force we have to find out in horizontal direction. First force, we have this component, weight component. It is acting similar to the same direction, so it will be a positive value. So we have to take the positive sign for of that. So first one is 73.5 73.575 cos of 50. Okay, and what else force we have? So we have, that is one more force, that is the force F, which is unknown. Okay, so that will be plus F. Then we have a frictional force which is acting opposite to the direction, so minus mu A into normal is 56.362 Newton. This will be equal to mass of A is 7.5. Here we will be using mass, and acceleration will be as it is, A. Okay, so 73.575 cos 50. So better I'll just calculate this value as well. So 73.575 cos 50, I got value as 47.293 plus F. So here the mu value is 0.25 into 56.362. It is equal to minus 14.091. This will be equal to 7.5 A. And we can keep the equation in the form of F and A. So F, if I take this plus 7.5 to the equal to the other side, will become minus 7.5 A, and this value will be equal to 47.293 minus 14.091. So I got the value as plus 33.202. This will be equal to 0. So what I can do is I can keep it in the terms of constant will be equal to constant. So this will be equal to minus 33.202. So this is my first equation from the block A or mass A. Now we have to consider the second block, considering FBD for block B mass B. Okay. Now similar manner, we have to draw the same FBD for block B as well. We have inclined force, inclined surface is 40 degree, and we have a block of B. This is a B block. So we'll have the one force will be acting normal perpendicular to the block, that is N. So now the same thing, the direction is downward. Direction is downward, or else acceleration of the block is downward. And we have a weight is also acting downward. So here the 27.5 kg is the mass of the block into 9.81. This gives me 27.5 into 9.81 is equal to 269.775. So again we'll have a inclined with respect to y axis. I'm going to take with respect to x axis. So this gives me 50 degree. So I'm going to resolve the weight into two component. One is cos component, horizontal one, 269.775 cos 50, and one is vertical component, 269.775 sin 50. So we have converted in the two components. Since the direction is downward, we'll have the frictional force in the opposite direction. F of F will be equal to mu B dot normal. Okay, now if you look at the diagram, because of now the same similar manner, because of block A, so again because of block A we'll have a force on block B as well. Okay, so it will be in this direction, upward direction. Okay, so here the force will be in the upward direction. It is in the opposite direction like this. This is your force. Okay, so this is the complete FBD for the block B. So by again same thing, by using Newton's second law, we know that. So here I'm going to use f of y will be equal to find the normal, f of y equal to m into ay. So ay will become 0 because the acceleration y direction will become 0. So f of y will be equal, gives me n minus 269.775 sin 50. This will be equal to 0. So n will be equal to 269 into sin 50. So this gives me 206.659 Newton. For the block B, the normal reaction is 206.659, and f of x will be equal to m into ax. So for block B, so if you see what are the forces we have in horizontal direction, we have 269.775 cos 50, 269.775 cos 50. It's the same direction as the block as well, so positive. And we have the frictional force, which is a negative, that is mu b. Mu b is 0.1, and normal we just found out, minus of 0.1 into 206.659. And we have one more force, that is a unknown force, which is acting opposite to the direction. So minus f. This will gives me, this is equal to block B mass is 27.5. This is equal to A. Now we'll see the calculation. 269.775 cos 50 and minus 0.1 into 206.659. I'll get it as 152.742 minus f. This is equal to 27.5 A. So I'm going to rearrange the term. So it will be in the form of f plus 27.5 A equal to 152.742. So this is my second equation from the block B. So we have to solve the equation 1 and 2. Solving equation 1 and 2, you can put it in the calculator, you get the equation, and if you the value will be for acceleration will be equal to, it's 5.313 meter per second square, and the force between the two blocks is F will be equal to 6.642 Newton. So this is our required answer, the force between the block A and the B, or mass A and the B. Okay, so I hope you understood this problem clearly. If you have any doubt, you can put it in the comment section. Thank you for watching.